All right, so once again, we're going to do a quick run through of this diagram. The PCs already have their addresses. You can see the addresses are assigned in the different locations here. We're just going to click on the device, and then we're going to configure the interface addresses. We're going to do this one, and we're going to do that one. We're going to do this one and that one, this one and that one, and so on. And we're going to work our way across until we get all the IP addresses configured on here. We're going to configure so that we can use Telnet to remotely connect to one of these PCs. Along the way, we're going to do various tests with ping, maybe traceroute. And finally, we are going to go into these routers, and we are going to configure the RIP, Routing Information Protocol. It's a interior gateway routing protocol, and we're going to configure RIP so that these devices will all share all the routes that they've got with one another. So go ahead and just watch what I'm doing here. I'm going to go up to this one, which simulates our CenturyLink device on the edge of our network. And I'm going to show you this. And of course, we know that when the continue with configuration dialog box shows up, the answer is always no. That message means that the configuration has either never been configured or was not saved. So I'm going to type enable to get into the enable mode. You'll see the prompt changed from the greater than sign to the hashtag. We're then going to get into the what's called global configuration by typing configure terminal. And remember, if you wanted to, you could just type CONF space T or anything in between those two. Once we're in here, we're going to type host name, and I'm going to host name, and we're going to call this one CenturyLink to simulate our CenturyLink router and access point. And then now that we've got that, we simply need to go into the interfaces and configure their addresses. And since they look a little small, I'm just going to blow them up a little bit. I'm going to get back into the commands on this. And the first one is going to be interface gig 01. And you can see that right there. It shows it, and it also shows it on the link. If you want to turn the extra identifiers off, you can just go up to the top to, is that options or is that options? Preferences on the options, and turn off the port labels. See how that cleans the diagram up so much. We don't have all that extra clutter on there. So we're in this router. We're going into interface gig 01. You notice the prompt has changed from config to config IF for interface. And we're just going to put an IP address, 192.168.0.1 with a 255.0 and a no shut. Very quick and easy. From there, we're going to go to the next one, interface gig 00. We're going to type in IP address, and that one's got a 71.209.223.29. It says /30, which we will learn is 255, 255, 255, 252. And we typically use that type of subnet mask on a WAN connection. And we'll do a no shutdown. So that router, those two interfaces are now up. If I want to configure a password on here so that not just anyone can plug in this console cable and get in, we're going to have to put two types of passwords. One, we're going to put an enable password of, and I'm going to do all caps Cisco. And so now we have a password on there, which if we go all the way out, when I hit enter, I'm already in, but when I type enable, I have to put that password, and it's all caps CISCO. All right, from there we're going to go config T, and I also want to put a password on to prevent us from plugging this cable in. And that password is going to be on the console connection. And so we're going to do a line con 0. And don't worry, we're going to do this numerous times. So you go line con 0, password of lowercase Cisco, and then we're going to use the word login, which means require login. I'm also going to do a logging synchronous so that we don't get interrupted with the syslog messages. And I'm going to do an exec timeout of 0 minutes, 0 seconds, so that like it never logs us out of the device automatically. in a lab environment, that's helpful. In production, you probably wouldn't want to do that. Finally, that we've got that part of it done, I'm just going to do a, because I'm in config mode, a do, and then a copy, run, start to copy the running configuration to the startup config. All right, other than the routing protocol, most of what we've done here is complete, except for one last thing. I'm going to do a do show run, and I want you to see that that password is in clear text. Not a good situation. Somebody that's shoulder surfing can see that. So to protect that, instead of using enable password, we use enable secret. And I'm just going to use all lowercase Cisco, since all of our passwords will be Cisco. Then I'm going to do the up arrow to bring back my copy, run, start. Hit enter twice and save that. Let me do a do show run. So you can see that, and you'll see that password is encrypted right there with an MD5 hash. All right. So I'm not enabling Telnet yet. I'm going to come back for the Telnet. Let's go over to Edge 1 right here. So I'm going to go into this one. And once again, we have the, do you want to continue with the configuration dialog? The answer is no. We'll do an enable. I'm going to do a config T, and I'm going to do the enable password of Cisco and an enable secret of all lowercase Cisco. Now, when you have two of these here, if you have the secret, this one will no longer work. From here, I'm going to go into the line con 0. I'm going to put a password of Cisco, the word login, the logging synchronous, and the exec timeout of 00. Now all I need is the IP addresses. Interface gig 00, IP address 71.209.223.29 with a 255, 255, 255, 252, and a no shut. Okay. Uh-oh. Sorry, on that command, I need to put a 30 on there. The other side. This side is 29 down here. This side is 30 up there. And so I'm doing that interface. It is now correct. Let's test that. Let's do a do ping to 71.209.223.29. And our link, there we go. See that? We were able to successfully ping across this link from this side to this side, testing connectivity. Incidentally, ping is a layer 3, uses a layer 3 protocol called ICMP, but ping itself is a layer 7 application layer protocol tool. All right, let's go into the other interface. Interface serial 000. The IP address is 12.0.0.1. Once again with the 255, 255, 255, 252, which is the 30-bit subnet mask. I'm doing no shut. And I'm not sure, it's a serial interface. Maybe I need clocking, maybe I don't, but I'm going to put a clock rate of 1 million. And if I wasn't sure if I needed clocking, there's a command I can use. It's do show controller, serial 000, and you'll see that on the third line of the output, it says DCE. And it's a V.35 connector on it. The clock rate was just set to 1 million. This DCE stands for Data Communications Equipment. That's typically the router with a modem in it, and it needs, to me, that means clocking. The C stands for clocking. The other side, over here on the other side, is going to be DTE. All right, so I'm going to just do a and I'm going to change the name of that. I'm going to change that to hostname, capital Edge 1, and I do a do copy run start. Yeah, I'll go over that again. All right, so I'm going to go over to the next router here. Data Communications Equipment is what DCE stands for, Data Communications Equipment. All right, so right here we are in the continue with configuration dialog. The answer is no. I'm going to go enable config T, and I'm going to type host name, and I'm going to call that Edge 2, And then from there, I am going to go into enable password of all uppercase Cisco and enable secret of lowercase Cisco. And I'm going to then do the line con 0, password Cisco, require login by typing login. Then I'm going to put the logging synchronous and exec timeout of 00, and we'll go in and put the addresses on. So we're going to go to interface 0000. Now, let's say I wasn't sure if I needed clocking or not, and I wanted to know if this side was DCE, data communications equipment, or the alternative is DTE. Now, typically clocking is going to be provided by the service provider on a serial connection, but in some instances, we may need to know how to do that. So I'm going to show you how to tell if this is a DCE or a DTE connection. If it's DCE, it requires clocking. If it's DTE, it does not. And that command is going to be the do and then show controller 0000. I want to see with the controller configuration. And if you look on the third line right there, you see that? DTE. That means I don't need to provide clocking on this side. As we saw on the other side had the DCE, data communications equipment. This is data terminal equipment. So, and it does not require the clocking on this side. All right, so we now have the enable passwords configured, the enable secret configured, the name of the device configured. We're going to go, and the line console connection. Let's go into interface 0000 just to make sure we're in the right interface. The IP address is 12.0.0.2. It's got a 30-bit mask on it of 255, 255, 255, 252. And I'm going to turn that interface on with a no shutdown command. Look at that, it just came up. Now, if I want to verify if the link's up, I can do a do show IP interface brief, and watch what happens. It shows me that the serial interface is 12.0.0.2. It's up. Then on the status, that means if there's a cable connected. And over here on the protocol, that one is up too. This is the data link layer is operational. So the physical layer is operational and the data link layer. Physical, data link. It's up. We would typically say that it's up, up. It's happy, happy. The administratively down means that the command shutdown has been done. So let me do a shutdown, turn the interface off, and I'm going to redo the command, and you'll see it now says administratively down. If I do the no shutdown, and I can do the show IP interface brief, it's up and down. It's not up yet. It's going to take just a moment for the communications to negotiate with the other side. Look at that. It just came up. So we can look at it again, and we'll see it's up, up. Happy, happy. All right, let's just test do ping 12.0.0.1. Okay, so we can now ping from this side to this side. Oh, let's see. Do you think we can ping over here? Ping, let's try it. 71, 209, 223, 30. Sorry, I got to put the word do in front of that since I'm in the config mode. It's not able to communicate. And the reason why is because it doesn't know where to send the traffic, because it doesn't know anything about that interface, that address. And if we want to view the routing table, from here we can just type do and then show IP route. And you'll see the only routes we know about is this one, which we just configured. It knows about this interface right here, directly connected. It's a link. It knows only about this one. It doesn't know about what's over here. The way we're going to learn about what's over here and over here and over here is by using a routing protocol. And a routing protocol is going to share the routes between the routers. All right, let's go over to gig 00, interface gig 00, and we'll do an IP address of 136.0.0.1. Once again, we have a 30-bit mask, 255, 255, 255, 252, and we'll do a no shutdown to turn the interface on. And that's a gigabit interface with Ethernet, so I don't have to worry about any clocking on that. Clocking is only necessary potentially on serial links. All right, so let me just do a do show run. I want to verify what I've done. I've got my name, my passwords. I can spacebar to go a screen at a time. I have IP addresses configured. That's all good. Down here, I've got my console connection configured. Everything looks excellent. Let's do a do copy run start and enter twice. Finally, we're going to go over here to the other side. This is our branch office. And this is a Cox communication device on the other side. So I'm going to name that Cox. Enable. And then we'll do a config T, host name, Cox router. And we're going to go enable, password. Now we're just doing the enable so that you'll learn the command. Enable secret, Cisco, line con 0, password, Cisco, login. That means require login. You must put a password to connect to the console port. Now we'll do the logging synchronous. Synchronous. There we go. And the exec timeout of 00. The console is now configured. Let's do the interface gig 00. IP address 136.0.0.2. Mask is 255, 255, 255, 252. And a no shut. Look at that. Came up and up. But let's just verify. What's the command to verify? Do, show, IP, interface, brief. Look at that. We are up and up. We got an address. You can also just do a do sh, IP, INT, BR. That'll show the same output. So you can type the whole thing out. You can type the shorthand out or anything in between. We are up and up, happy on those interfaces. Let's go to interface gig 01, IP address 172.16.01, 255, 255, 255, 0. That's a 24-bit mask, and we'll do a no shutdown. We'll see that the link has come up. We are connected on this side to a switch. The switch is currently amber on its light, meaning we're not moving traffic yet because it's going through the process of something we'll learn about later called spanning tree. It takes 30 seconds for that light to turn green in a non-optimized device. We'll learn how to speed that process up later. All right, so let's just do a do ping. The test 136.0.0.1. That's pinging across this link right here, right there. And we see we were successful. That's because if we do a do show IP route, good commands, we have the 136 network right there. We have the 172.16. Here's the 136 network. Here's the 172.16. All right. All right, so we've got everything configured in terms of IP addresses and the console connection. The next thing I want to do is just show you, and it's going to be repetitive commands, how to configure the Telnet lines. So we're going to go, I'm going to exit back, so right there. We'll do a line VTY, that stands for virtual terminal. We're going to do the lines from 0 to 15, a total of 16. We're going to do a password of Cisco, login, logging synchronous, and exec timeout of 00. Do those commands look familiar? Those are the same commands we used on the line console. So now we can actually telnet into that device if we have connectivity to it. Very simple to telnet. All right, so we've done that. But I don't want to have to type those commands every time. Let me do a do show history. Look at this. These last few commands right there are the line console. See that? I'm going to hit copy on that. On PuTTY, you just do Control-C. I'm going to go up to this device. I'm going to right-click and paste. That device is now configured for the Telnet. I'm going to go over to this device. I'm going to right-click and paste. That device is now configured for the Telnet. I'm going to go over to this device. I'm going to right-click and paste. Now, incidentally, on live equipment in PuTTY, The moment you right click, whatever is in the clipboard, you're not going to have to click on paste or anything like that. As soon as you right click in that window, it's going to paste it. Okay, so just to test, I'm going to go to Edge 1, and I'm going to show you how to Telnet into here. Now, in order to Telnet, we have to be able to ping. So let me do a do ping, and we'll just test it. 71.209.223.29. I can ping from Edge 1 over to here. I can ping from here to here. So the Telnet is very easy. You just change the word ping, and you don't have to ping, but it's just a way of making sure you have connectivity. You just type Telnet, and then the address of the router you're trying to Telnet into, and watch this. I hit enter. It popped up, and look at that. It asked me for the password. So I'm going to type Cisco, and look at the name of the prompt has now changed to CenturyLink. This is the device I am currently connected remotely. I'm connected remotely into the CenturyLink router. Let me do this. Enable. Oh, look at that. It asked for a password. We know, of course, it's Cisco in this lab. So we are set and ready to go. All of our devices have now been configured to permit Telnet. Finally, I said what we're going to do is we are going to configure a routing protocol. We are going to use RIP, or Routing Information Protocol. Routing Information Protocol. That's the name of the protocol. And it's very simple to do this. Let me do a do show IP route before I do it. Sorry, let's do a show IP route. And you'll see we don't have any dynamically learned routes. And we'll talk about how routers learn routes later. Basically, they learn any interface that has an address on it. It knows about those because they are connected. That's what the C means. We can also statically configure a route on here if we want to. We typically use that for a default route. We'll talk about that in a few days, and we'll have the internet connected up here then. And finally, they can learn it with a routing protocol. Today we're going to do the routing protocol approach. So we're going to use RIP. So the command, I'm going to get back into the configuration mode, and I'm going to type router RIP. I want to use version 2, so I'm just going to type version 2. That's going to change the protocol, the way it operates a little bit. It's going to allow us to also share the subnet information when we're doing the updates, which by default are sent every 30 seconds. We'll always send every 30 seconds. And then we just need to do 2 network statements. And we're going to do 1 network statement for this network right here. And we're going to do 1 network statement for this network right here. So I'm going to just type network 192.168.0.1. Actually, 00 is the network. And then we're going to do network 71.209.223.28. That's this network. Now you can actually, if you wanted to, I could type in the 01 and I could type in the 29. I could type in the actual address of the interface, and it will correct it and make it this or this. And I'll show you how that works. I'm going to do a do, show, run. And when we get back down here, you'll see it automatically converted those to the network address and not the actual physical address. So that's cool. Let's do a do show IP route. Okay, we haven't learned any routes yet. And why not? Well, the reason why not, we've only configured this device. When we configure this one will then learn about this network, because this router is going to tell it, hey, I know how to get to the 12.0.0.0 network. So we're going to see that route appear over here. And we're also going to see the 192.168.0 route. We're going to see that one be shared by this router and told to Edge 1. So these routers are going to tell each other that they know how to get places. Kind of like I might tell you, hey, I know how to get to San Diego. You take Highway 8, Interstate 8. All right, so let's go over to Edge 1. Very simple configuration. Router RIP, version 2. And we're going to do 2 network statements. Network 71.209.223.28. Actually, I'm just going to put in the actual address of the interface. And you'll see that it's going to convert it to 28. And then we're going to do the other side, network 12.0.0.1. 0. I'll do that one with the correct network address. And watch this. Do show run. Look at that. It automatically. Oh, I had another network state. Did I type 71? I must have typed 71 in there. Oh. 71, 209, 223, 30. 71 is a class A. That's right. So it converted it to the network address. All good. We got the 12. We got the 79. Did I do the 192, 168? I must have already had it in there somehow. That doesn't need to be there because that network doesn't even exist. So I'm actually going to do a no network 192, 168.00. Do show run again. Just clean that up a little bit. So we're on edge 1, this router here. We've done the router RIP. We did version 2. We did a network statement for the serial link, and we did a network statement for the Ethernet link over here. And let's do this. Do show IP route. And is it going to know about this route right here? What do you guys think? Yes, it is. Look at that. It's already showed up. Oh, I'm at CenturyLink. Oh! Why didn't you guys tell me? I'm telnetted into the CenturyLink router. I'm not even configuring. The correct router. Let's go back to CenturyLink. Let's fix this. All right, so we need to go to, all right, on the CenturyLink, darn it. We're going to do router RIP version 2, and network 192.168.00, and do show run. And we don't need the 12 on that one. No network 12.0.0.0. Okay. That bad move. All right, so we got to see a little live troubleshooting. You guys didn't even tell me. We were accidentally telnetted in and configuring the remote device. That's just a lesson right there. You got to be careful when you configure it. If you're telnetted in and configuring the wrong device, you could potentially lose all connectivity to it. So be cautious. So let's do a do show IP route. Okay, we're not learning any routes with RIP yet. When we do, they'll have an R over here. Let's go back to edge 1. Let's start over. Router RIP, version 2. I did this on purpose so you could see the commands twice. Network 71.0.0.0 and network 12.0.0.0. Watch this. This 12 network is now going to show up on CenturyLink. So if I do this, you'll see the 12 network. See, it was learned with R, with RIP. It'll show you right up there. It was learned with RIP. The 12 network is now reachable. So on edge 1, sorry. If we do a do show IP route, you'll know we see that we also have a RIP learned route here. We now know how to get way over to here. So let's just do a test. Do ping 192.168.0.1. Look at that. We have success. We can now ping from here all the way over to here. Do you think we could ping this machine? What do you guys think? Let's try it. Now it takes a moment for ARP. Look at that. We were successful. See that? Y'all see that? So we're able to ping from here to this router and then all the way down here. And then the answer came back from here to here and from here to here. Awesome. Let's try this right now. We just pinged 192.168.0.6. Let's go up to this router. Let's do a do ping 192.168.0.6. We're not going to be successful. And the reason why is because this Edge 2 router does not know how to get to that network. You can't get to San Diego if you don't know the way. You can't get to the PC down in the bottom left-hand corner if you don't have a route. Let's just verify. Do show IP route. We're going to see if the route exists. No, of course not. The only route that does exist is that there are two directly connected interfaces. This one, 136.0.0 right there, and 12.0.0 right there. Those are directly connected. That's the first way a router learns a route. What's the first command to configure the router for RIP? Router RIP. Second command is going to be version 2. And then we're going to need two network statements. Network 12.0.0.0 and network 136.0.0.0. And now that we have done that, let's just do a quick verification. Let's see if we can ping way down to the other side. Watch. Before you do, let's watch. Look at that. We were able to ping. See that? A minute ago, we didn't have a route to the 192.168. But if we do the show IP route right now, now we have the route, and it was learned with RIP. Is that cool or what? So before you ask a question, let's just do one more. I may cover it through this process, and then we will cover any questions you got. Let's do router RIP version 2. Let's do a do show IP route just to verify there's no routes yet. We do network 136.0.0.0 and network 172.16.0.0 for these two interfaces right here, this one and this one. We have now configured those. Let's go over here and let's see if we can do, let's do the show IP route. Look at that. We learned about the 12 network. We've learned about, from here, we learned about the 12 network. We learned about the 71 network right here. And we learned about the 192.168. We've learned a lot of routes. Let's try our ping again. Maybe we didn't ping from this one yet. Let's do a do ping 192.168.0.6. Control Shift 6 will break that. And 0.6. Look at that, we're successful. Awesome. Okay, we're now able to ping on our diagram from here, through there, through there, through there, all the way down to here. Let's just go to this PC right here, and let's test that ping from there. Let's do a desktop command prompt. Let's verify we have an address, IP config. We do have an address, 172.16.0.6. We're going to ping 192.168.0.6. And look at that, we are successful there. And if we want to see the path that the traffic took on a Windows machine, we just try trace RT. Look at that, we can see each hop as it goes all the way to the other side. All right, so that's just a quick run through on that lab of the configuration of the IP addresses, the configuration of the console connection, the Telnet connection, and router RIP. Now, I just want to do one last test. I forgot, this machine over here, I want to put a description on the interface, but I am currently connected on, let's say, this router over here. Can I Telnet into this router? Could I Telnet into there? Yes, because I can. If I can ping it, let's try pinging it. Let's try pinging 192.168.0.1. Okay, that's the interface right here. Let me try and Telnet. Do Telnet 192.168.0.1. Now, Telnet means it's a tool that allows me to remotely connect and enter commands on the remote device as if I'm sitting at it. The device could be anywhere on the planet. There's my password, Cisco, enable, Cisco. I am now in privileged mode. Configure, you know, the privilege mode or enable mode, because I have a hashtag or pound sign right there. Let me do this. Interface gig 01, interface gig, sorry, I gotta go to config mode, config T, interface gig 01, and I'm gonna put a description of LAN connection. I'm going to do a do, copy, run, start to save all the configuration. And then I'm going to hit Control Z and exit out. Do, copy, run start. All right, and let me just suggest to you guys that that lab is pretty much done in terms of what we wanted to review today. It took about 20 minutes, maybe a little longer. So we should be good to go. I want you guys to do that same thing, and then we'll build this on live equipment.